All right, today we're going to dive into some science that honestly looks just like a magic trick. We're going to uncover how everyday items can reveal secret messages and create these amazing color changes, and it's all thanks to some really cool, kind of hidden chemistry.
I mean, really think about it. Have you ever seen something happen that just blew your mind, made you think, no way, but deep down you knew there had to be a logical, scientific reason for it?
Well, that's exactly the kind of thing we're talking about today. Imagine this. You're at a science fair. Someone hands you what looks like a totally blank sheet of paper. They give it a little spritz with a spray bottle, and bam, words appear out of nowhere. It's an awesome trick, but how on earth does it work? Let's figure it out. To crack this case, we're going to have to put on our detective hats. We'll gather the clues, we'll look at the evidence, and we're going to piece together the science that makes this magic totally possible.
You know, every good detective needs a special tool, right? Well, for us, that tool is something called an acid-base indicator. Think of it like a chemical spy. It changes color to reveal the secret identity of other stuff, telling us if it's an acid or a base.
So let's grab our first clue. It comes from a classic detective tool in the chemistry world, the good old litmus test. It's one of the simplest, most common ways to start telling these two chemical opposites apart.
So in the experiment we're looking at, they took some simple litmus paper and tested stuff you'd find around the house, like lemon juice and soap. This is going to give us our first solid piece of evidence.
And here's the big takeaway, the fundamental difference. Acids, which often taste sour, they turn blue litmus paper red. Bases, which can feel kind of slippery, do the exact opposite. They turn red litmus paper blue. It's a simple thing to remember. Acid red, base blue.
And would you look at that, the results are crystal clear. Lemon juice, which is an acid, turns that blue litmus paper red. A soap solution, a classic base, turns the red litmus paper blue. And what about plain old tap water? Nothing. No change at all, which tells us it's neutral, right in the middle.
But here's the really cool part. You don't need a fancy lab for this stuff. You can actually become a chemical detective right in your own kitchen. There are indicators all around you.
For example, you can make a super powerful indicator with just red rose petals. You just crush them up, add some hot water, let it sit for a few minutes, and then strain out the petals. That colorful liquid you have left, that's your very own homemade indicator.
And check this out. When you add an acid, like a little bit of lemon juice, your rose water turns red. But if you add a base, like that soap solution, it turns green. A totally different set of colors, but it works just as well as the classic litmus paper.
Okay, this quote right here is such a perfect aha moment. We've all been there, right? You get a stain, you scrub it with soap, and it changes color. That's not a disaster, it's a clue, and it leads us straight to our next key piece of evidence.
The secret ingredient in that curry stain is turmeric, and what do you know, it's another fantastic natural indicator. It normally stays yellow, but the second it comes into contact with a base, like soap, it turns this deep red. That color change is a dead giveaway about what soap is.
All right, let's recap. We've got our suspects, acids and bases. We've got our detective tools, all these cool indicators. Now, it's time for the moment where it all comes together, the big reveal.
This is really the heart of the mystery. They're chemical opposites, so what actually happens when they finally come face to face? They don't just hang out, they react, and it's pretty dramatic.
Well, this awesome reaction is called neutralization. The acid and the base literally cancel each other out. Their special properties just disappear. And what are you left with? Something totally new, a type of chemical called a salt and good old H2O, water.
And if you boil it all down, this is the basic formula. An acid plus a base gives you a salt and water. But see that last part? Heat. That is a super important clue. This isn't some quiet, cold reaction. It actually releases energy. If you are holding the test tube, you literally feel it get warm.
But this is way more than just a neat trick you do in a lab. Neutralization is happening all around us, all the time, and it's solving some pretty major real-world problems. Let's see why this actually matters.
Like, think about this. An ant bites you, right? It injects this nasty formic acid. But if you rub on some baking soda, which is a base, it neutralizes that acid and makes the sting feel better. Or farmers use a base called lime to neutralize soil that's gotten too acidic so their crops can actually grow. And factories add bases to their acidic wastewater to protect all the fish and life in our rivers. It's a huge deal.
Okay, The moment of truth. We have all the clues. We know about acids and bases. We know about indicators, especially our key witness, turmeric. It is time to solve that science fair mystery once and for all.
And here it is, the secret message. It was just written on the paper with a simple soap solution, which we now know as a base. Once it dried, it was totally invisible. The magic spray they used? Just a turmeric solution. When that turmeric indicator hit the basic soap writing, it did what it always does. It instantly turned from yellow to red, and poof, the message appeared. It wasn't magic at all, just some really clever chemistry.
So, now you're in on the secret. The next time you see a curry stain change color, or you use baking soda to soothe a bug bite, you'll know exactly what's going on. You're a chemical detective, and you're watching a neutralization reaction. The real question is, what other bits of everyday magic are you going to spot now that you know what you're looking for?